everyone, my name is Sonia Han, and I would like to start by thanking Seismic for sponsoring this tech talk. Today we'll be discussing microservices, a powerful architectural approach in building software. Today I'll cover what microservices are, the benefits they offer, how they communicate, and some key challenges. What are microservices? Before diving into microservices, let's examine the traditional way of building software, the monolithic architecture. Let's say you built a monolithic e-commerce application. In your application, every functionality like checkout, products, shopping cart would exist in one code base. While this type of applications are simple to start with, they have limitations. Technology lock-in. Because everything is developed, deployed, and scaled as one unit, the application must be written with one tech stack with a single runtime. Higher infrastructure costs and less flexibility in scaling. Since all functionalities are tightly coupled, even if you only want to scale a single service, for example, your shopping cart service during the holiday season, you would have to scale the entire application, which can lead to higher infrastructure costs. A challenge related to CI/CD pipeline would be slow development. Let's say your e-commerce application has hundreds of thousands of services with tests that need to be executed for each pull request. Even for a minor change in your code base, you will have to wait maybe for an hour or two for your pipeline to succeed. If it fails for some reason, you will have to wait another hour, which can lead to slowing down your development process. Lastly, high dependence between services. This one's pretty straightforward because each service is highly dependent on each other. When one service fails, it can bring down the entire system. And the solution to all these issues was a microservice architecture. Microservices are an architectural approach where applications are built as collections of smaller, loosely coupled, and independently deployable services. Each service has its own code base, focusing on a specific business function that can be deployed independently. Let's go back to your e-commerce application. Each of your microservices will serve one business functionality, such as checkout, products, shopping cart, etc., etc. And each of them should be self-contained and independent from each other, including database and data management model. Now, let's take a look at a real-world example to understand the benefits of microservices. This image shown here is the entire architecture of Netflix with over 1,000 microservices. Netflix was one of the first companies to have successfully migrated from a traditional monolith to cloud-based microservices architecture. In fact, they implemented this architecture long before the term microservices was even introduced. Now, let's go over a brief history of how and why Netflix changed their entire architecture. In 1997, as you all know, Netflix started as a mail-based DVD rental business, and their application was a single deployable unit with a monolithic database, which means that the database was a possible single point of failure. In 2008, there was a major database corruption issue due to which Netflix could not ship any DVDs to their customers for 3 days. And it became clear to them that they had to move away from a vertically scaled architecture prone to single points of failure. In 2009, they began their migration process to the cloud. And another fun fact here is that they've decided to move their services to AWS, which is one of their competitors, and they're now one of the biggest customers of AWS. So by December 2011, Netflix had successfully migrated its entire operation to the cloud, so from monolith to microservices. So it took almost 3 years for Netflix to shift to microservices. But what were the major benefits that made this worthwhile for Netflix? First, it's scalability. Microservices allow each service to be independently scaled to meet demand for the feature it supports. This allowed Netflix to overcome its scaling challenges and service outages. By 2013, Netflix's API gateway was handling 2 billion API requests managed by over 500 cloud-hosted microservices. Also, as you can see in the chart here, from 2008 to 2015, the overall viewing grew by about 1,000 times. Beyond that, Netflix also saw significant cost savings after their cloud migration, reducing costs per streaming dramatically. There are also other benefits of microservices, such as agility, technological freedom, and resilience. Now, if you have hundreds of thousands of microservices like Netflix does, and they are isolated and self-contained, how do they communicate to each other? A very common way of microservice communication is using RESTful APIs. In this model, a service makes a direct API call to another service and waits for the response before proceeding to different tasks. This synchronous model is ideal when you need an immediate result, like a user account confirming payment with the payment service. Another common way is using asynchronous communication, which allows microservices to interact without waiting for immediate responses. Unlike the previous model, in this case, services send messages to a message broker like RabbitMQ or Kafka, and this broker acts as a middleman queuing and delivering messages. Another way of communication that is becoming pretty popular, especially in Kubernetes environment, is a service mesh. A service mesh provides a dedicated layer called control plane to manage network communication between microservices. Also, instead of embedding network logic within each service, you offload it to a network proxy called sidecar that sits alongside your microservice. Now that we understand the benefits of microservices and how they communicate, it's time to talk about some major downsides. First, they increase operational complexity. And we can think of it like this. With microservices, instead of maintaining one large building, you're now managing a whole town of smaller houses. Each of them would need plumbing, electricity, internet service, and this can quickly become overwhelming without the right tools and processes. Another challenge is distributed data management. As we discussed earlier, each microservice has its own database. How are we going to ensure that all data stays in sync? For example, if a user updates their profile and that data lives in the customer service, how do we make sure the order service reflects that change? This requires a proper data management tool. Lastly, there are observability challenges. I think this image perfectly captures the concept. Basically, without proper monitoring and logging tools, debugging would be like solving a murder mystery. To wrap up my talk, I wanted to share this article, which talks about how Amazon Prime Video team migrated their video monitoring service back to a monolith. Their experience highlights that the ideal architecture depends on specific use cases. In this case, the switch to a monolith improved their performance and reduced costs by 90%. I think it's a valuable case study demonstrating that the best architecture is the one that best solves your specific challenges. For those interested in diving deeper, I highly recommend checking out their story on their blog. Now that's my work cited. I'd like to thank Seismic again for sponsoring this tech talk, and I'll stick around for any questions afterwards. Thank you.